Right, so let's move on to question number 17. A reaction which is non-spontaneous at room temperature and 1 atm pressure becomes spontaneous at high temperature at the same pressure. So we already discussed this about this temperature and different pressure conditions where once reaction which is not spontaneous becomes spontaneous, or either one reaction which is spontaneous become non-spontaneous. Okay, so the first thing that you need to understand is at room temperature, okay, the reaction is non-spontaneous. That is what they say. At room temperature, the reaction is non-spontaneous, which means at room temperature, its Gibbs free energy should be a positive value. Okay, and they're asking which of the following is correct for the reaction at room temperature. So they are asking the Gibbs free energy, enthalpy, and the entropy values at room temperature. Okay, so we have discussed this type of questions many times. I'm telling this again. So the idea is this. So delta G is anyway positive at room temperature, and we need to find which values of delta H and delta S would make this delta G positive at room temperature. Okay, and also don't forget, they say when you increase the temperature, delta G becomes negative. So you need to find that factor as well. So at room temperature, delta G is positive. So if delta H is positive and if delta S is positive, okay, so if delta H is positive, this delta H component will be positive. If entropy is positive, this whole component will be negative. So there will be a positive negative product that is that determines this Gibbs free energy value. Okay, for an example, this would be like positive 200, and since entropy is positive, this will be like minus let's say minus 100 for an example. Okay, so the answer for this is plus 200 minus 100, which means plus 100, where our Gibbs free energy is plus 100. So okay, it's okay. So this condition is possible. So let's go to the next one. So if this is positive, so if this is positive means let's take the same value. So if this is like plus 200, and if this is negative, means here negative times negative is going to be multiplied. So it is like minus 100 times minus, so it will be plus 100. So here the overall amount is like plus 300. Okay, and here it is plus 100 for this particular case, first case. And this one, if this is negative means let's take this as minus 200 for an example, and this is positive. So this is positive means this would be also minus something, for an example minus 100. So this is minus means your delta G will be minus. Okay, so this is not a case. Then negative to negative also will be like this. Okay, so it is not equal. For if you put negative to negative, for an example, this is negative 200 and this is negative, mean this would be positive. Okay, so this will be a positive let's say positive 300 at room temperature, because then it will be like the delta G will be a positive value here, right? Delta G will be positive, like positive 100. So the two cases that gives you a positive delta G would be this one first, which gave us like plus 100, and this one, and this one. So there are three cases. Now what we need to check is when you increase the temperature, this delta G value should reverse to give a negative value. Okay, so we'll come from the back. So the last step, this the entropy is a negative value, and negative times negative, which becomes this positive. So if you increase the temperature more and more, there will be higher value for this, like for an example, plus 400, right? Because here the entropy is increasing. When you increase the temperature, this whole product is going to increase. So for an example, here it will be from plus 300 to 400. Okay, nothing happens to entropy, temperature is increasing. Okay, and the entropy that we took here is negative one. Don't forget that both are negative. So if this is more positive, you would get more positive result for delta G. So this is not a case that will give or reverse the delta G when you increase the temperature. And the second one is again very similar, because this is a positive value. This is also a positive value. So you will never going to get a Gibbs free energy that is negative. So the only possible option is this. How? See here, if delta S is positive, you increase the temperature, means you will going to get a more negative answer here, because positive times negative is negative. So for an example, initially we use this one as 200. So when you increase the temperature, this minus 100 now will be like minus 400. So our result is now a negative value, minus 200. So we see here delta G can be reversed. So the only option that can be taken is this one, where at room temperature, our delta G can be positive, enthalpy can be positive, entropy can be positive. So all are positive. All are positive. Answer is first one. Okay. Okay, so this is the explanation. However, it is very easy if you remember as well, right? So if, because this type of questions comes. So this is the what way where they say at room temperature, it is non-spontaneous, and when you increase the temperature, it becomes spontaneous. So you should remember at room temperature all should be positive, because when you increase the temperature, it becomes negative. The delta G becomes negative. So this is the case. In the similar way, you can also remember the reverse case, right? You can also think about like this. Okay, it is spontaneous at room temperature, but non-spontaneous at higher temperatures or lower temperatures. So this is what we discussed when we discussed, I think, one of the earlier papers. So you should remember this one as well.